really excited to introduce our two guests here in just a moment, but before I do that, as always, we like to start with a little bit of a story. And this story goes back to my days as CEO of a pretty decent sized manufacturing company up in the Fox Valley here in the state of Wisconsin. And we used to hear from our educators, our high schools, and our community and technical colleges from time to time, asking to partner, asking to learn more about each other, and so on. I want to tell a story about one particular high school, and I certainly mean no disrespect to this high school in telling the story. It's really just an observation on where the world of additive manufacturing was about 5 years ago. And so I got an email from an administrator at one of the local high schools, and it was an invitation to come see their manufacturing learning labs. Now, being a person who spent 20 some odd years in manufacturing, I was more than eager to go and see a high school manufacturing learning lab. I wanted to see what our young people were learning about that great world where I had chosen to make my career for several decades. And so we went on a tour, and it was a great tour, and they took me into a room. And what I saw was a bunch of students and a bunch of items that look like these little contraptions that look like that. And I guess I knew that that was a 3D printer. Admittedly, I didn't know a ton about 3D printing, but I knew that it was a 3D printer. And they showed me how they were downloading files from the internet and then producing little figurines. And they were actually little figurines, believe it or not, of Yoda. Now, look, I love Yoda. As those of you that work with me here at ATS Lab Midwest know, regularly, if we say we're thinking about doing something, if somebody has the guts to say, well, we can try, my answer is always to quote Yoda and to say, do or do not, there is no try. So I love Yoda, but I can also tell you that I'm not sure that those students were learning a ton about manufacturing just by printing out those little yoga figurines on their 3D printers. And so the individual who was offering the tour said, so what do you think? And I said, well, this is really cool. I mean, it looks like you're teaching some cool, maybe design concepts and so on. I said, I'm really excited to see the manufacturing area. And they looked at me a little bit dumbfounded. And it became pretty clear to me that that was their manufacturing area. Now, especially at that time, I had seen 2 3D printers in my life. I saw one way deep into the product development program at Harley-Davidson, where we needed like 3 levels of clearance to even be in that room. I had seen one at Mercury Marine where they were using it to develop some new products. Those were the only 2 3D printers that I had seen in industry up until that point. So I had to explain to that administrator that, what they were doing was interesting, but at least in my mind at that point, it wasn't manufacturing. So a lot of people asked us about 3, 4, 5 years ago, why aren't we doing more in additive manufacturing? Why aren't we selling 3D printers like everybody else? And my answer was, when we can prove that students are learning industrially relevant competencies, we will be all over additive manufacturing. But until that day comes, we are not going to get into the business of just selling equipment to somebody to use it to print Yoda figurines in a classroom. Well, that day that we dreamed of started coming. And my view of additive manufacturing started to change. A couple of years ago, I took a trip. I took a trip out to the state of Massachusetts, to Boston, to meet with a gentleman by the name of Greg Mark. Greg, at that time, had founded and was the chairman and CEO of a company called Mark Forged. And I could tell right away after I had the opportunity to meet Greg and Jason Rose and other members of their team that this company was different, that they were looking at additive in ways that nobody else was looking at additive. And instead of thinking about how do we print a little figurine, I heard him talking about things like we're printing work holding fixtures for CNC machines and end of arm tools for robots. Those were the applications that I saw in additive manufacturing. They even had the guts to tell me, as I continue to believe, that additive may never replace technologies like injection molding or die casting or machining for all the applications, in part because of the cost associated with additive versus traditional methods of manufacturing. But using additive manufacturing to augment the world of manufacturing and to print parts that otherwise could not be manufactured, that's where the future was. And that's where we got interested in Mark Forged. So we're going to learn a little bit more about that today. I'm welcoming today 2 great guests. The first one is a gentleman by the name of Sean Pepper. Now, Sean is a 5th-year teacher at Baldwin Woodville High School. That's in northwestern Wisconsin, for those of you that are familiar with the state of Wisconsin. He graduated from UW Stout where just tons and tons of great technical education teachers graduate from here in the state of Wisconsin in 2016. And he talks about the fact that his college career gave him tremendous opportunities to incorporate design type instruction into his program. Says Sean, technology is always changing and developing, and I do my best to incorporate that in my curriculum in order to prepare my students for college and or a meaningful career in a technical field. So Sean, thank you so much for being with us and welcome to the program. And we are going to now go ahead, Sean.
Yeah, thanks for having me.
That's great. It's absolutely great to have you. So thank you so much. I'm now going to introduce my friend Ron Olson. Ron is the instructor and program director for the Mechanical Design Technology program at Madison Area Technical College. He's part of a great faculty, and I know a number of Ron's great colleagues as well. He's been teaching there, believe it or not, for 28 years, preparing hundreds and hundreds of students for careers in design-related fields. He's has a very successful collaboration and design projects with examples like Bucky on Parade. So Bucky was actually a project that we had the opportunity at ATS Lab Midwest to collaborate on. All of those Buckies, if you're familiar with that effort in the city of Madison, were painted using Fanuc robots. So we had helped provide to the college and to the program. So Ryan had another role in that project, very impressive. The TRB project, a face mask strain reliever for local healthcare workers, and he's worked closely with Madison College's Entrepreneurial Center in the submission of student projects as intellectual property. Before he joined Madison College, he was a special projects engineer for Penda Corporation. So great industry experience, and actually began his career as a high school level teaching, drafting at the LaSalle Peru Area Vocational Center in LaSalle, Illinois. So Ron, welcome to you as well, and great to have you on the program today.
Thanks, Matt. Happy to be here.
Absolutely. So we're really, really looking forward to all the great things that our guests are going to learn today. And Sean, I want to start with you. Tell us a little bit about where additive fits in your existing courses at Baldwin Woodville.
Yeah, so right now I'm teaching engineering, woodworking, carpentry, our intro class, which we call applied tech. In the spring, I'll add architectural drafting to that. So engineering is really where I do most of my 3D printing. It's only one class, so it's not a huge part of my day. But I just want to explain just real briefly my engineering class right now, because I'm probably going to be referring back to it. So the first quarter, the first 6 to 8 weeks, roughly, we go through and we do project on each of our piece of equipment. Now, we don't technically have a fab lab, but we have fab lab type equipment. So we've got our laser engraver, our 3D printers, and our CNC router, our vinyl cutter. So we spend time going through so that students will learn the equipment. And then the second half of that class is where we get into a lot more 3D printing. We go to mechatronics type of instruction. And then that's where we start really doing some cool projects. So that's really where I really get into my 3D printing with students.
So covering some pretty advanced learning already at the high school level, which I got to believe, Sean, tees your students up really, really well for whatever comes next, as you said in your quote earlier, whether they're going direct to workforce or going on to technical college or to a university. Just great experience they're getting there at Baldwin Woodville High School. When they do leave and move on, some of them may end up at Madison College and Ron Olson's program. So Ron, same question for you. Where does additive fit in your mechanical design program?
Well, Matt, you can see based on the illustrations on the screen, it's really throughout our program. I teach with 2 other great instructors, J.R. Colvin and Ryan Ubersox, and they teach throughout the program as I do. I teach much of the second year classes, but a little bit of the first year with SolidWorks. And you can see, on the screen again, that what we try to do is incorporate the 3D concept of spatial relationships and just building that skill and introducing 3D printing wherever we can. One of the things I think that jumps out to me when you look at this illustration I have on the screen is that we definitely have a skill building concept throughout the program, but we definitely get into more project-based curriculum in the second year of the program, and 3D printing supports all that student project work for us.
Outstanding. And by the way, I know you're two co-instructors as well, and I'll say the same thing that you just did, which is just a fantastic group of people that you have the opportunity to spend your days with. So obviously doing great things there at Madison College. I want to talk a little bit about introductory projects, and as we put a slide up here that I shamelessly stole from the Baldwin Woodville website, Sean, I want to talk a little bit about, as your students are getting into 3D printing and understanding additive, what are some introductory type projects that will build their interest and their competencies?
Yeah, so at the middle school, that is kind of where they're introduced to 3D printing in our district, and that's where they're kind of doing the Yoda figurines, like you mentioned earlier. So then once I get those students, then we move on to a little bit more advanced. So now I'm talking about kind of the first 6 to 8 weeks of my engineering class. So they're learning some CAD software, as well as, you know, our specific 3D printers and stuff like that. So I got one project here I wanted to show. It's a coin separator. So it's kind of a design problem. They're cleaning out their vehicle. They have a lot of loose change, and they want to design a device that will separate the coins. They can count them easier. So here I've got what it looks like. Handful of change. Just kind of set it on the top there and give it a shake back and forth. And then eventually you'll have coins separated onto each different tray. So we got our nickels, pennies, and dimes. I didn't have any quarters, so I couldn't include that with that.
It's absolutely a perfect demo, Sean, and thanks for sharing that with the team. I want to say that actually made the ATS Lab Midwest highlight reel. So last year, I think in our 2019 highlight video, I think that was one that showed up there, which was just a really unique application. And what I love about it is the ability for your students to relate to something usable, but also get engaged in the design, problem solving, and production process all at the same time. So Ron Olson, I want to pose the same question to you as your students are beginning their program. Talk a little bit about some introductory projects that they'll experience.
Yeah, so building off the previous slides from the previous question, you know, as we move through our curriculum, you know, I think one thing that we've really prided ourselves on over time and, you know, just try to continually improve upon is this idea that you see on the screen of within each class, we really try to build ideation. Once we get ideas, we try to collaborate across classes. So we're not building islands of classes, we're building a network of classes with cross collaboration. And throughout that, there's just tons of opportunities for teamwork and collaboration to build on those ideas. So that concept just goes a long, long way. As you know, we try to get as much mileage out of that as we can with the project. When we get an idea, how far can we take it? We've had a vice project that introduces our students to lots of things in terms of solid modeling, a little bit of 3D printing, manufacturing processes, and they physically build a machine tool vise. With our whole environment this year with COVID, we've had to switch and adapt and do some different things. And in one of my second year classes, we decided to come up with another project and wanted to streamline it a little bit. And the slide that you see on the right-hand side here on the screen is a gear puller. So we took a problem, a gear puller problem out of the Giseki book, the Giseki that I learned on and way back in the 6th edition, now up to the 14th, 15th edition. And we took that gear puller problem and we posed it to a team of students and said, all right, how can we design for X? And we, you know, whether it's manufacturing, whether it's assembly, you name it. And we broke it down as a design problem, and we did all that virtually. We've been teaching virtually for much of this. So we had teams working virtually. We had interaction in the design, pulling up models, evaluating the design online. And just this morning, Matt, I finished off the Mark Forge machine here, our Mark II, the final version of that gear puller. So it turned out reasonably well. We got a few adjustments we're going to have to make, but this was a student design problem. They uploaded the models. I downloaded them, printed them here at my house, and really went through a nice design process using 3D printing to prove out the design and get us ready for that next step.
Absolutely. I love that. And really in the same sense as Sean provided, exposure to, not just the application, not just the printing, but really the design side of it and the problem solving side of it. There's just so many great opportunities for us to teach these competencies and really important competencies using additive manufacturing and using 3D printing. So great example, Ron. I want to stay with you for the moment and just, kind of playing off of the whole Yoda topic. And again, nothing against Yoda and nothing against getting young people excited about additive, getting excited about STEM using 3D printing. But give us some examples of some authentic design process opportunities where students are really learning that application.
Yeah, well, first of all, one of the other instructors, Ryan Ubersax, does an outstanding job with our first year students, just teaching them our design process. So we have our own adapted design process model that we designed for our program at Madison College. And so Ryan introduces that design process to our students, and then we try to carry that theme of how things flow through a design process. So, instead of just randomly downloading something, we're always looking at how does it fit? When it comes into the design process, what are customer requirements? What's the design for X? How does it have to meet, the end objective? And then how do we take it through the sequential steps of that design process? So, throughout the program, design is just inherent in everything that we do and following a process. And, one of the things you see on the screen is a capstone design that it was for making cheese curds. And we had a team as a capstone project last year that took a Nesco cooker and designed an insert vat type system that would go in and make cheese curds. And they were just on a phenomenal track of designing that last year when COVID hit. And unfortunately, we didn't get to the end result and never got to taste those final cheese curds. But, they were following a design process, and this is their concept drawing that really lays the foundation for all the project management and the planning that would form, the base for that design process. So I can't stress design process enough in everything that we do.
Absolutely. No, it really, really is important in terms of getting students those competencies again, understanding how do we solve a problem, how do we design a solution. Certainly those of us in Wisconsin know no stranger to the whole world of cheese curds. And maybe in as much as they weren't able to finish the project, a lot of folks are probably at home eating them to pass the COVID time, right?
There you go.
So Sean, I'd love to pose the same question for you. Talk a little bit, especially at that high school level. How do we drive home the authentic design program and process for your students?
Uh, what works well for me is to include more specifications or more constraints on whatever product that the student is designing. I kind of wrestled with that a little bit early on when early on in my career. But I found that it really helps if I include more constraints and give the students an actual scenario. Like, for example, with the coin separator, I tell them, let's go out to the parking lot, let's go through your cards, let's pull out the change that you find in there, and now let's design something that will actually solve that problem. So it works really well to give the kids, and they get pretty fired up about it too, to give them an actual scenario or a design challenge. And then with that, they prove their designs and why they made it a certain way.
Absolutely. So moving from the authentic design process and into this whole idea of what competencies we're teaching, which I think, Sean, are probably pretty closely related to that design process and others. Can you, and in the interest of time, I want to make sure I give both you and Ron plenty of time to show off your capstone projects. So maybe in a 30-second answer or so, can you share some core competencies that your students are learning in your program?
Well, yeah, a lot of mine are aligned with the Wisconsin Tech Ed standards. But just for example, the coin separator that I talked about, we're talking about accuracy and precision, identifying the differences. We're talking about tolerance, applying the measurements to a specific design, um, defending their design, justifying why they made it the way that they did, and being able to collect data, in this case, measurements of coins, and how to incorporate that into a successful design.
Perfect. And Ron, same question for you on core competencies. How do those differ at the community college, technical college level?
Just focusing specifically on rapid prototyping, you can see on the screen here the major competencies in bold, number 1, number 8, 15, and 20 that are listed there. We have 4 different types of 3D printing process that the students are introduced to. So they get a wide variety of technology that they're exposed to. One of the biggest things, though, that I see with 3D printing, and as it relates to the competencies, is that, where are you using the 3D printing and where are you in that design process? And what I mean by that is that, like for example, this that I printed out today had a little problem with the fit of, there's actually an Acme thread here and a piece that has the thread onto that Acme thread. So our manufacturing tolerances are a little bit different than our 3D printing tolerance. And sometimes we have to adjust our sizes a little bit just to get a working model so that it fits the 3D printing process. One of the students didn't quite give me enough tolerance here, and I couldn't quite screw it on as easily as I could. So, that's one thing. What are you designing for? Is it 3D printing? Is it for manufacturing? The other thing that we really like to emphasize is the top right slide. And I had a student last year. He did download this, by the way. It was a full model that he downloaded, a Briggs and Stratton engine. But he broke that model completely apart, used SolidWorks to model every component on there. And that is fully 3D printed, is what you're looking at, a model that turns, the shaft rotates, the piston goes up and down. It's phenomenal.
That's awesome.
Out of that, what I really take out of that is attention to detail. And you can talk about technology, you can talk about all kinds of things that go into design, but one of the core competencies is attention to detail in my mind. So attention to detail goes a long, long way.
Absolutely. Well, and I'll be honest, Ron, when you shared that slide with me, I was a little bit wondering what the Briggs engine, how that was going to fit into your presentation, and how that makes sense to me. That's incredible that's all 3D printed by one of your students. Very, very impressive. So speaking of students and speaking of great things that they're doing, I wanted to talk for a moment. Sounds like we're in a high school, right, Sean, with the speaker going on.
Sorry.
No worries at all. That's what it's about. That's it's learning at work. I want to talk about capstone projects, and I've been in both. Certainly, I've been in Ron's program, and I know Mike Dietrich has spent time in yours, Sean. Ron, tell us a little bit about the capstone projects that your students are participating in as they kind of cap off their learning before they head out into the world of employment.
Yeah, Matt, we've evolved to something now the last, I don't know, 5-6 years here of how the students present their projects. And, we're talking about a second-year project that is intended to incorporate lots of aspects throughout the program. It's intended to have collaboration with other programs. We try not to be the end-all, design it, build it, wire the electronics. We like to get our electronics program involved when possible. We'll get our machine program involved. We've even got the culinary program involved, depending upon what we're looking at. So how can we simulate an industry and be like a design department and work across different departments? So we've evolved where the students create their projects and they plan for them in the fall of the year. And we're going through a new set right now. And in the spring of the year, they present. And we've evolved to what you see on the bottom right is the Shark Tank approach. And basically the students have to own their project. They have to know every inside out detail of it, get up in front of our advisory committee members and sell their product. Why is it a good product? What did they go through to create that product? And they get grilled every once in a while. They have to know what's going on with the product. So it's been a great experience to not only design, but be on the other side of almost a sales presentation point of view and have that speaking ability to be able to sell their product. Going around on the screen here up on the top left, we had a phenomenal student last year. He'll be joining Sean here soon in the high school or in the public school setting. We had a student that Brandon Rip was his name, who's becoming a tech ed teacher. He took some classes with us and he went through our project management class, and he developed that Partia is the name of it. And basically it's a remote device that shines a laser beam light to help you locate your vehicle when you pull into a garage. And what you see on the screen there, he fully designed, fully 3D printed in his house and made a working prototype. And it was just phenomenal. Top right, outstanding student John Lash was part of, actually on the bottom right, the umbrella for the wheelchair is what you can barely see there. John has a degenerative disease, and through that he's taken an interest in adaptive design. And after graduating with us, he took a leap of faith and decided to try to do some business on his own. And he has a seat over at Sector 67 in Madison. And he got connected with the lady that you see on the screen, who has some physical disability, but has just a beautiful creative mind and artwork. And she needed a tool to be able to create her paintings. And John made 3D printed that device that essentially is a catapult that's able to splatter paint, and so that she could create her designs. And John was a real gift to us too. He just brought a real sense of creativity to our program, and he's out doing great work in the adaptive field right now.
And what a touching story that is, Ron.
Oh,
And just, I mean, it's just absolutely incredible. And to see, in the end, that's what this technology is all about, right? It's about improving lives. It's about making people's lives better. And what a great example for John to be able to share, and a great opportunity for him to share with that young lady who is obviously generating and gaining incredible benefit from that. In the interest of time here, I want to go over and make sure we give Sean just a minute to share his capstone project, and then I think that'll probably bring us to about the end of our time here with Webinar Wednesday. But Sean, why don't you just chat a little bit about what you have going here? This is a video and some slides that you had shared with us. Tell us about this.
Sure. So the video that you see on the left there is that is a Skittles machine from last year. So their capstone project, they will be designing a machine that will dispense Skittles. It's automated and programmed by using the Arduino board that you can see on the picture on the right. So there we've got a lot of electrical components, and that's kind of where our mechatronics comes into play. So they've got their Arduino board, and then usually most of them will power it by a servo motor or a stepper motor. And attached to that motor will be some sort of moving part, and that's where the 3D printing really comes into play. Along with that project, they'll be using all of the other equipment that they've learned. So you can see that the plexiglass there, that was cut out using the laser engraver. Some of the parts on the side there that were cut out using the CNC router. So we're kind of incorporating all of the equipment that the students have learned, and a lot of the concepts that they've learned by doing those smaller projects earlier in the school year, kind of incorporate all of that into one project here at the end. And they usually end up being pretty cool, and it's really interesting to see what the kids come up with, because a lot of the time it's something I wouldn't have even thought of myself, and they end up being a lot of fun. The kids like it, and I think they learn a lot from it.
So quite a bit further along than that Yoda program that I saw in the high school about 5 years ago, right, Sean? That's absolutely incredible.
Yeah.
And for our audience that recognizes that technology, obviously just a tremendous amount of mechatronics and high-tech related, advanced manufacturing related technology that those students are learning in the program. I'll tell you, my biggest regret today was that we didn't have more time carved out for our two guests. This has been a really interesting conversation. I think we probably have another 3 or 4 questions that we'd like to get to on another episode. So let me ask Sean and Ron, by a nod of the head, would you be willing to join us again sometime to share out the rest of all of this information with our audience? That would be absolutely fantastic. I think, Ivan, again, in the interest of time and our commitment to try to keep these right around a half hour for our audiences, we're going to duck into our conclusion here. And by way of that conclusion, what we have coming up here in just a week from today on Webinar Wednesday is a presentation of thank yous. And so Ron and Sean were both willing to share thank yous with us earlier this week when we put this webinar together, thanking people that have been important in their life in the world of technical education. We have videos coming in from people all over the Midwest, all over 7 states, that are sharing why they love their job and what they're thankful for in the world of technical education. We're going to share those back with you next week. So if you haven't gotten your video in, don't miss this opportunity to submit your video so we can show off all the great things that you are thankful for. Just send it to us here at ATS Lab Midwest. I want to thank Ron Olson of Madison College, and I want to thank Sean Pepper of the Baldwin Woodville School District. Sorry, Sean, for being with us here today. What a great discussion. What a great presentation of advanced manufacturing technology and great applications for additive manufacturing. To everybody, thanks so much for being here. We will see you again next week.